Hello everyone! Today we're working on this Ecostar A automatic garage opener PCB. Customer has sent me these pictures. One time the sticker, PCB, where you can actually see heated up connections here. This is how it's set up. So you have the PCB here, motor, transformer and some sensor. And it's the last PCB from the top. Let's fix this undocumented unknown board. A bad technician would go ahead and just replace this burnt resistor. I mean, it's obvious, yeah? It's burnt. But no, resistors don't burn for no reason. Resistors burn on the PCB when too much current is flowing through it. This means you have to find out on which side the current goes in, on which side the current goes out, and what on the output side has pulled too much current. A burnt resistor is just a symptom and not the actual cause of the problem. Let's try to understand the PCB to understand what could have pulled this amount of current. So, we have got the power input here. Yeah, we saw that the transformer is connected to it. I was able to read off the transformer that it's a 20 volt AC transformer. So it takes 220 volt out of the socket and outputs 24 volt AC. Then we have a bridge rectifier. It's this 4-pin component here. Yeah, you can see its markings here. When you Google this, you will find bridge rectifier. A full bridge rectifier turns AC voltage into DC voltage. So, bridge rectifier output is rectified DC voltage. You can calculate this voltage by multiplying with the square root of 2. So we need around 33.94 volts on the output of the bridge rectifier there. The voltage is then going through this diode here, hidden next to the relays, to be used as the coil voltage for the relays. But it also loops under the resistor, back through the resistor to the spot here. Here it then goes into this LM317, which generates a 24 volt rail on the output on the middle pin. This 24 volt is then going to this transistor to the next here, which is a BD139. Which is controlled by this LM358 to output a 5 volt rail. So, to recap, 30 volt here, 20 volt on this guy's output, and this guy is then supposed to output 5. Just for better understanding, I've drawn this diagram. So, you can see here, 20 volt AC from the transformer comes in and goes through this bridge rectifier. Yeah, it then goes through the diode and is also used for the relays down here. Yeah, but most importantly, this is our 33 ohm burnt resistor. So let's mark it as red burnt. We have the LM317, which is has two resistors here and a Zener diode for adjusting the output voltage to 24 volt. So we must see 24 volt here. 24 volt goes to a few other places on the board. But anyways, this then also goes here. This is 24 volt and usually goes through this BD139 to generate this 5 volt rail, which goes to the sensor, to the PIC and to the EEPROM on the board. So all kinds of stuff. This BD139 is driven through the base pin by the LM358, which is a dual op-amp. This dual op-amp first takes a VCC voltage of 24 volt of the LM317 and it connects to ground here. It then takes a Zener diode to clamp the 24 volt down to 5.6 volt because Z3 is a 5.6 volt Zener diode. This circuit works to regulate 24 volts down to 5 volt because the op-amp buffers the voltage set by the Zener diode. When the output emitter voltage, so the 5 volt drops, the base emitter voltage between here increases, which increases the base emitter current and thus increasing the collector emitter current and the emitter voltage, so it regulates itself. Thank you for Stefan from the Joyless Tech Discord for explaining the circuit to me after I made this schematic. To limit the damage, I disconnected and unsoldered this transistor here, yeah? So it could no longer output the 5 volts, so in case high voltage went to my 5 volt rail, so 24 volt to 5 volt, it wouldn't blow up my sensor, my PIC and my EEPROM. Then I checked what base voltage I got, okay? And I got 24 volt. So the LM317 was working, it was outputting 24 volt, but I also got 24 volt on my base here. This means this transistor was like, it was like shorting through, it was like opening, and it was putting the full 24 volt down to my 5 volt rail. This PCB can not work like this, and yeah, as I said, this thing has to regulate itself, and we only need 5 volt in the output. So I went tracing back. The base voltage is wrong. So I went here to check who sets the base voltage. The LM358 is just used as a buffer. So I found that the in plus 1, so this input here, was also 24 volts. This is when I finally concluded that this Z3 Zener diode here must have gone open circuit. As you can see in this picture here, it only has 2 connections, so I'll wire it up to my component tester and we will check what it says. And yes, this Zener diode is definitely faulty. Here are the part numbers in case you're wondering what to order. And here's the new diode and resistor. So let's check our resistor. New one is 33 ohm. Good. Old one, the burned one, is 12 mega ohm. That is faulty. And on the Zener, you can also check them without a component tester, of course. Just go on the correct legs. This one is open circuit. This one has a voltage drop like this. Let's get out the faulty components here. Okay, I've added some flux. And let's populate the resistor. I know this one is a bit bigger. I have slightly overspec'd. Can handle more current. And that doesn't have to be a bad thing. Oh, and yeah, I unsoldered this transistor, so I'll put it back. 1 second. If you are like me and you want to test the board before putting it back into the garage, you can just set a bench power supply up with 17 volt and limit the current at like 500 milliamps, and you will see that the thing starts blinking. Right now I'm getting a 8 times blink error code. And this just means that it didn't have a reference way yet, so it didn't have one drive-through to find its outer parameters. This is normally expected when you have disconnected power from this board previously. And just as a little proof here, I will raise the voltage up to 30 volt, so we can actually measure the output voltage. And first of all, we have 24 volt here and 5 volt. Very good. Very, very good. I will now install the relays and clean the board from all the flux here. And this is fixed otherwise. Thanks for watching, like and subscribe if you liked the video, and see you in the next one. Bye.